Tip number 4, goal seek. This was added, about at least 8 or 9 years ago, maybe even longer. But goal seek is an engineering tool and it allows the user to select a variable that needs to be calculated or modified based on the change of another variable. So in the example I'm about to show you, I have a bottle and I need to know where the fill line is. So I need to know how high up the bottle to get a half a liter in there. And in the demo, I'll explain a real life situation where this could be handy. So let's just run the demo and it'll explain it a lot better than this slide can. To demonstrate the goal seek command, I'm going to go back to an old tips and tricks where I showed you last year how to create the volume block inside of something like a bottle so you can measure volume. First of all, you notice I have the bottle here. I've created this plane. And if we edit this plane, you can see it's a set distance from the base of the bottle. And the goal here is to determine this height to make this fill up to half a liter. So I created a surface on here. As I mentioned before in the previous tips and tricks, we showed you how to use the intersect command to get a solid to calculate volume. So we'll do that. Remember, you have to create a design body. And we're going to create a design body based on the void region. And we'll accept that. So we have this void region. Now the first thing we need to do is calculate the volume of that void region. So we'll go in and we'll activate this body. And then we'll go to our inspect, select our physical properties, and update it. You will get this error because you haven't put in a material, or I haven't put in a material, but I don't need the material to calculate the volume. You'll notice the volume's not coming out in the units that I expect, so let's close this. We'll go to our application, and then we'll go into info file units. We'll change our volume units to liters. And now if we go and look at this, you'll see right now we have just over half a liter. So we want to adjust this so we get exactly a half liter. And this is where the goal seek comes into play. So under tools, if we have a look at our variable table, you'll notice that the volume is showing up down here. And that 140 value of that plane height, I went in and typed in it a name, called it full line height. So now what I can do is I can go to my inspection tab and run my goal seek. So what's my goal? My goal is to adjust the volume to the target of 0.5. And to do that, I'm going to adjust the full line height variable. And I'll run that. I'll use the default here of 60 seconds and a maximum of 300 iterations. That should be enough. Now, when I accept this, you'll notice this plane will start moving up and down. And the system's adjusting it, looking for the right height to give me this target value. Now, before goal seek, if you were trying to do this manually, you would go in and adjust it down a little or up a little and slowly work your way into finding that half liter. And this is exactly what goal seek is going to do for you. Now, it's going to end when it's finished or if it times out. Now, if it does time out, it's advisable to rerun it and give it a longer time and more iterations. Usually the default, the stuff I've been working with, the default has been sufficient enough time to give me the results that I want. So we'll just let this finish, and you can see it's finished now. So we'll close this, and let's go back to our variable table. And you'll notice now that the volume is indeed at half a liter, and our height is 129.69 millimeters. So we now know exactly how fill to make this bottle if we want a half a liter. I worked summer jobs at Alliance Canners, and they canned Pepsi products, and we had a machine that on the line that we would set a laser, and we called it the low fill machine. And if the bottles or cans went through and the system detected it was below this line, they would be rejected. So this would be a good example of where you could use the goal seek to find out that exact line and make sure that anything that was below this line is rejected. Let's go back to our presentation. Tip number 5, solid sweep. This was added a couple of releases ago. Now, prior to joining Design Fusion, I worked in the tool and die industry, and a lot of times, rather than actually designing or drawing in 3D what we wanted, they would give us the 2D and say, okay, make this as wide as the tool that you're going to use to cut it. With solid sweep, we can now do that right inside the CAD model. So we can take a solid and sweep it through another solid using our multi-body approach. So for example, if you're creating worm gears or drills or tooling, this would be a good opportunity to use this. So let's have a look at this. To demonstrate the solid sweep command, I've created a multi-body part here. We have the shaft, which is the active part, and the taper tool. And I've also created a path to follow using our helical curve command. We'll go up and we're going to do a cutout here. So we'll do a solid sweep cutout. And I'm going to select first the path, accept it. Then I select the tool and accept that. You'll notice because I was using a cylindrical shaped or conical shaped tool that automatically defined the center axis for me. So I'm going to accept that. And now it wants me to lock the direction of the sweep. So I'm going to use this center line here to do that. We'll accept that. And then it'll generate the feature for us. The time it takes to generate depends on the complexity of the tool and the path. And you can see it's gone in and created our solid sweep for us. So I'll hit finish. And then I can hide the unwanted components here. And you can see we now have a very nice cutout feature using a solid. So if you're doing tool generation, worm gear generation, this type of stuff, it's a very powerful tool to assist you in your modeling. Now the next 3 tips and tricks I've combined into one demo. So let's look at the tips first. First thing is a custom part or sheet metal template. Now, a lot of our customers make custom templates for draft, but I don't see a lot of them using this in the part or sheet metal. There's a huge advantage to this. You can save time on repetitive work. It reduces errors. It can capture company standards and capture custom properties. So a good example is, let's say you manufactured sheet metal products and you only work with 3 gauges. You could create a template that includes just a standard shape, a tab, for example, with random dimensions on it. You could fill in your gauge property and your thickness and everything and save that as this is my 12 gauge template. Then you could have your 10 gauge template and your 8 gauge template or whatever. And then when somebody starts that part, they open up that template and then they just have to modify the dimensions of the tab to get started. They don't have to fill in their gauge properties, this type of stuff. So to do this, you would start with an existing template. You modify settings, properties, and add a base feature. Then you can save the template with a unique name and store this template in a template folder. Combine that with custom properties. Now there's two ways to create custom properties. You can go to your custom property in your file properties tab, or you can expose a variable and give it an exposed name. The names can be identical or they can be different. And the nice thing about custom properties is anything that is exposed, you can then use later using your property text callout. For example, you could add information to your parts list or to a callout or to a title block. So anytime these are exposed and put into the custom properties section, they become available for use downstream. And the tip number 8 is the quick sheet templates. This was added back in V15, so quite a long time ago. And it allows you to capture the views and then extract the parts out of them, but maintain those views to be used by other components. So when you set up a quick sheet template, once you have that set, you can drag the component in from the Pathfinder and it automatically populates with those views. Quick sheet templates can only be created using the create quick sheet template command, and I'll show you that in just a minute. When you create a quick sheet template, all drawing views on all sheets are emptied, including parts list. Almost all view properties, including general properties, text and color properties, and annotation properties are maintained. And this is what makes this so powerful. So I'm going to show you a real life scenario where we use this to help out a customer. To demonstrate the last 3 tips and tricks, I'm going to use a real life scenario. A customer of ours designs and manufactures stainless steel kitchens for a very popular fast food restaurant. And a common part of his is this, what you see on the screen. It's called the creased panel. And these vary in sizes, and they're used to cover cutouts for hydro, electrical, and gas, for example. So he's always making different ones of these. And his original process was that he designed one of these and made a print. And then what he would do to speed the process up, every time he got a different size, he would photocopy this, white out these values, and put in new values and send that out to the shop. So I came up with this solution for him that would be more accurate and just as fast as doing the whiteout and photocopying. So we modeled up this part, his most common shape one. We put in some PMI here, so he had clear visualization of what the dimensions were. And then we went up and we created some exposed variables. So you can see here we have the width variable, and I exposed this and gave it the same name, and the length variable. And there's other variables here that have been exposed for other reasons. So once you've exposed the variable and give it a name, this will show up in your file properties. So if we go to our file properties here under Info, File Properties, and you'll notice the Custom tab, and you can see that all the exposed variables are shown up here. Now at this point, I saved this and gave it a very unique name. We also created a sort of master draft file. And you'll notice down here, we put in a little parts list. Although it's not really a parts list, we used it to create the name, length, and width. And it is created as a parts list, but we save this in here like so. And this will be his master draft file. So now that we know that this is the master, I went and created a quick sheet template from this. And to do that, you go to the settings and click on create quick sheet template. You will get a warning saying to make sure that you save this, because once you hit yes, the part connections will be deleted. So I hit yes, and I save this, and I gave this the same name as the file, but I put a QS for quick sheet at the end of it. So there's the quick sheet for our customer. Now I then will exit out of these, and I save these files into my template folder. Now, if you don't know about templates and how to create them and save them, I would suggest you talk to your systems administrator or call our tech line. But in a nutshell, there's two places you can save template folders. One in the template folder section of your installation files, and two, you can actually assign a folder for your templates, and you can place that assignment under file locations in your Solid Edge setup. So if you see here user templates, if your company's, say, for example, put a folder on the network, it'll point to where that location is. So how did this benefit my customer? Well, let's have a look. So if he has to create a new one, he would start by going to New, and he would go to his custom template. And you can see I've created a folder for my custom templates. And I go down and we'll open up that template that we had saved. Now at this point, he sees the original, so he can go into the variable table and change those values. So let's change this to 20. And we'll change the length to 30. You'll notice that this is automatically updated. So he would then save this and give it a name. I'm just going to use the default name here. And then he could go up and say, let's create a drawing of an active model. He'd browse to his template for the draft, uncheck Run Drawing View Wizard, because with Quick Sheets, we do not want to run the Drawing View Wizard, and we'll say OK. And you'll notice not only does the view change and the dimensions update, but also the parts list is updated here. So very fast. Now he just prints this out and sends it to the shop floor. So not only does he have the correct dimensions, but he also has the correct scaling. This is very important for the shop to be able to see the scale and the dimensions, whereas before, a lot of times his drawings were out of scale because he was just changing the dimensions. So here's a good example, a real-life scenario of where a few templates and some custom properties significantly improved the workflow for this customer.
Now I know I can't see you or hear any of you, but I know some of you are going ooh and ah over that last tip like you normally do when you're sitting in front of me. The next one is relatively new. I think it was added 2 releases ago. It's the one body assembly. And what this allows us to do is use the part copy command, and we can bring in an assembly and convert it into a single body. So not only can you bring in the assembly to convert it, but you can convert just the configuration of that assembly as well. You can also control the coordinate system so you can make sure things align. You can remove voids if you wish. And the option that allows us to do this now is the adjust non-manifold conditions and merge. So let's have a look at how this works.
In this demonstration, I have this small engine consisting of several parts and a sub-assembly. And what I want to do is to convert this into just a single part. A good scenario for this would be if this is a supplier part and we order this as a single unit, it'd be nice just to be able to plug this into my assembly or draft as a single part, because I really don't have any control over the individual components of this since it's brought in from outside. So what I can do is I can go up and we'll start by opening up a new part template. And I'll then go and run my part copy command. I'll select the assembly from my directory. And you notice with the ordered paradigm, I have the option of linking to the file. I have the option of coordinates, selecting a different coordinate system to align with. I can even bring in just a specific configuration. But this is the key right here. What prevented us from doing this for a while in the past was that we would get non-manifold conditions come up. This was added several releases ago to allow us to adjust for non-manifold conditions and merge. We can remove void areas if we wish, and then we simply say OK. We now have a single part that we can insert into our larger assembly. Makes the assembly a lot lighter, and it's a lot easier working with just the single part engine than working with the assembly. Now, let's undo this, and let's do this in synchronous for synchronous users. We'll just transition to synchronous. It's the exact same steps. The only difference is you do not have the option to link this. If you've used insert part copy before in synchronous, you'll know that that option has disappeared. Everything else is the same. We'll say OK, hit finish, and there's my single part synchronous. So very useful tool for simplifying and working with supplier components, for example.